PU2 aspirants, so welcome to the channel, and your midterms exams are ahead. So in this video we are going to solve the theoretical and numerical questions from the chapter Electrochemistry. We have already completed one shot revision and one marker question, so I'm very sure that you're thorough with the concepts. So now let's do some question practice and make this chapter done for the midterm exams. So if you see in this particular electrochemistry chapter, you will get 2 3-marker questions in the theoretical part and 2 3-marker questions in the numerical part. Okay, so let's directly go to the theoretical questions. I have taken some very good questions from very good sources. So first one is from sample question paper 1 of 2025. Okay, means the exam that was conducted in 2025. Direct measurement of conductivity of ionic solution by Wheatstone bridge is not possible. Give reasons and suggest a remedy to resolve it. This question was asked in the pre-boards, midterms, a very important question. So here first of all, why we cannot measure it? The reason here is definitely first reason is you cannot connect the electrolytic solution to the Wheatstone bridge because it is a liquid, and the second thing is we use direct current in Wheatstone bridge, which is again not a which can change the composition of the electrolyte. These are the two problems. So what are the two solutions we have? First one very often is you have to use the AC current instead of DC current, and second one is to not to connect the electrolyte directly. We cannot connect it, but we can have a conductivity cell inside which you can pour the electrolyte and then connect the conductivity cell to the Wheatstone bridge. So here are the problems and the solutions. Direct current will change the composition and solutions cannot be connected. So the solution for that is instead of DC use AC, and electrolytic solutions is connected to Wheatstone bridge by using a conductivity cell. Okay, moving to the next question of SQP 1 only 2025, the theoretical questions. State Faraday's second law and mention any 2 factors which determines the product of electrolysis. So Faraday's second law states that when you give the same amount of current, the mass deposited is directly proportional to the equivalent weights. So I recommend you to remember the exact statement of the law from the NCERT book. Do not have your own creativity here, because laws, definitions are very critical thing and should be written in the way it is written in the book. Okay, so the amounts of different substances liberated by the same quantity of electricity passing through an electrolytic solution are proportional to their chemical equivalents. Next, products of electrolysis depends on the nature of the material being electrolyzed and the type of electrode being used. Now coming to the next, we'll go to sample question paper 2. Here the question was, plot a graph of molar conductivity versus root over C for strong and weak electrolytes in the solution. For strong electrolytes, write the equation that represent the variation of molar conductivity with concentration. So this is the graph for strong electrolyte and weak electrolyte from NCERT I have taken. You can draw this. So you should know that in weak electrolyte, the increase in molar conductivity will be much more than the increase in molar conductivity of strong electrolytes. And here we have an equation also to prove that. This equation is for strong electrolyte called as D by Huckel-Onsager equation. Okay, so you have to write this equation. Here this is what molar conductivity, this is limiting molar conductivity, this is constant, and this is the constant concentration. Okay, moving to the next sample question paper 2 again of 2025. During the working of Leclanche cell, write the anodic and cathodic reactions and what is the role of produced ammonia during the cell reaction. So anodic reaction, zinc undergoes oxidation here, and you have MnO2 which undergoes reduction here. And what is the role of this ammonia that is produced? The ammonia produced in the reaction forms a complex within Zn2+ to give ZnNH3 whole 4 2+. Okay, so 3-marker question, 2 reactions and 1 equation, 3 mark you will get. Next we have name the fuel cell. So this is from sample question paper 3. Name the fuel cell that is used in Apollo space program and write its anodic and cathodic reaction. Name is hydrogen oxygen fuel cell, that carries 1 mark. Anode, at cathode what happens? Oxygen get reduced, and at anode hydrogen get oxidized. So 2 reactions and the final reaction. This will give you a 3-marker answer. Okay, next we have sample question paper 3. Next question, mention any 3 thermodynamic properties that can be measured using the electrochemical cells. So you have delta G, delta H and delta S are the properties that can be measured using the electrochemical cells. We'll move to now 2025 actual paper that was conducted in the exam and some questions from there. So in the theoretical part question, write a neat level diagram, cell representation and the half cell reaction for SHE. This is a very prominent question. Every year almost it is asked. So first of all, a neat level diagram you have to draw like this. You have to draw the platinum wire, the platinum plate, the hydrogen gas, the bubble, the concentration. So this is a well level diagram for SHE. Next, what you have to do, cell representation. The cell is represented like this, platinum, hydrogen and H plus, and the half cell reaction. So half cell reaction is H plus plus electrons gives you half H2. So 1, 1, 1 total you will get 3 marks here. Next, moving to 2025, another theoretical questions. Lead storage battery is commonly used as a secondary cell in automobiles. So what is a secondary cell? And write down the reactions that occur at anode and cathode during the discharging of the lead storage battery. So again, what is secondary cell carries 1 mark, and during discharging the anode and cathode reactions carries 1 mark. So total you will get 3 marks here. So a secondary cell is a cell that can be recharged by passing current through it in the opposite direction so that it can be used again. That carries 1 mark. Anodic reaction where lead is getting oxidized to lead sulfate, and cathodic reaction where lead oxide is reduced to lead sulfate. Okay, so this total gives you again 3 marks. Now after 2025 paper, I have some most expected questions that you can predict. So the first one is, what is the role of salt bridge in connecting anode and cathode or 2 half cells? So 3 points you have to write. The first one is maintains a neutrality, prevents the accumulation of charges and avoids liquid-liquid junction potential. Okay, moving to the next one, what is the function of Daniell cell when if a potential is applied less than 1.1, equal to 1.1 and more than 1.1. So if it is less than 1.1 external potential you will give, it will work as a galvanic cell. Equal to 1.1, the cell will stop functioning. More than 1.1, opposite, reverse reaction will take place, or the current will flow in reverse direction. Okay, so it will work as a galvanic cell, then no reaction, and then electrolytic cell. Moving to the next one, how to determine SRP of copper using SHE. So this question can also be asked for SRP of zinc. So it is very simple thing. First of all, you have to take SHE on one side, and the element whose reduction potential you want to calculate, that has to be connected on the another side, and the difference has to be calculated here, right? So now if I check this, so standard hydrogen electrode is the reference electrode. The given copper electrode is coupled with SHE. The EMF of the cell formed is measured using a potentiometer. So the potentiometer is used to calculate that. Then the measured EMF of the cell, that is PT H2H plus, copper 2 plus copper corresponding to the equation. So whatever you will get the equation here, and this is the measured value that will be calculated here. The similar question can be asked for zinc also. You have to do it in the same way. Now coming to the next question, on what factors the metallic conductance depends? So there are 3 factors: nature and structure of the metal, number of valence electrons and temperature. Next we have, on what factors the conductivity of electrolytic conductors depends. So conductivity means they are talking about kappa here. Kappa depends on what factors? Nature of the electrolyte, then you have temperature, nature of the solvent and its viscosity, concentration of ions and the size of the ions. This question was also asked in March 7, 2017. Then we have explained the variation of molar conductivity with concentration. This is super important question. Okay, every year almost this question was asked some time ago. So we know that molar conductivity increases for both strong and weak electrolyte as the concentration decreases. Next point, for weak electrolyte the increase is more than that of strong electrolyte. Reason for that, in weak electrolyte there is increase in the dissociation of ions, that is why the conductivity increases, whereas in strong electrolyte it is increasing just because of the increase in the mobility of the ions, right? 3 points are written. Then you also need to draw the graph, this one. Okay, moving forward, state Colruy's law and give its 2 applications. So direct law is there, so you have to just write down. It states that the molar conductance of an electrolyte at infinite dilution is equal to the sum of the ionic conductance of the respective cations and ions. And what are its uses? It is used to determine the molar conductivity of weak electrolytes, and it is used to determine the extent of dissociation. Next question, how much charge is required for the following reduction? So if you have aluminium 3 plus to aluminium, so how much electrons will be required here? We will have 3 electrons, right? So that will give me 3 Faraday. Next, copper 2 plus 2 copper. Copper 2 plus 2 electrons will give you copper. So that will be 2 Faraday. Next we have MnO4 minus to Mn2 plus, right? So that is, okay, it is like this. So this is plus 7 to plus 2. So you have MnO4 minus gives you Mn2 plus. So here it is plus 7 to plus 2, that is 5 electrons. So this is 5 Faraday. This is 2 Faraday and this is 3 Faraday. Next, we have give reasons why zinc displaces copper from copper sulfate solution. Zinc displaces hydrogen from HCl but copper does not. Iron displaces copper from copper sulfate but copper cannot displace iron from ferrous sulfate solution. So this is all because of the reactivity series we know. So let's just understand the first one. So you know zinc is more reactive than copper. Higher it is present in the electrochemical series, higher to that of copper. So that is why zinc has a greater tendency to lose electrons. Okay, zinc can oxidize better, or zinc reduction potential is less. So copper will undergo reduction and zinc will undergo oxidation. So that is why zinc displaces copper from copper sulfate. So you can see here that zinc is undergoing oxidation and copper is undergoing reduction because the reduction potential of copper is more than that of zinc. Next question, zinc is above hydrogen in the reactivity series, so it can liberate hydrogen gas from the acids. Copper is below hydrogen in the, so it cannot displace hydrogen from HCl. So if you see the reaction, Zn plus HCl will give you ZnCl2 plus H2 gas is produced. Next we have iron displaces copper from copper sulfate solution. So definitely iron is more reactive than copper, it is present above it. So therefore iron can displace copper from copper sulfate. Copper is less reactive, so it cannot displace iron from the ferrous sulfate solution. Next we have question, this I have already discussed. So let's see the next question. Explain corrosion as an electrophenomenon. Okay, so this can be a long question, so you have to prepare it very thoroughly because you have a lot of reactions here. So please listen the answer properly. So first of all, why corrosion is an electrochemical phenomena? Because it involves the transfer of electrons, so it is called as electrochemical phenomenon. Now see, mechanism of corrosion can be asked in the examination. It is not yet asked, but a very potential question. Last year in some pre-board question it was asked, so please prepare this answer. You have to remember this answer properly. Okay, so how can you explain the mechanism of corrosion? So when iron object is exposed to atmospheric air, iron undergoes oxidation and acts as an anode. Okay, so when released electrons from the anodic spot, so from where the iron is acting as an anode, from that electrons will be released and to another spot on the metal and reduce oxygen in the presence of H+. Okay, so it reduces oxygen in presence of H+, which can act as a cathodic spot. So these electrons, so for example this is a rod. Okay, so from here oxidation takes place. So iron gets converted to Fe2+, and the electrons moves to a different position, and the electron which moves to a different position can reduce the oxygen in the presence of H+, which acts as a cathodic spot. Now at anode what happens? There is oxidation, and at cathode there is reduction of H+. Now the overall cell reaction is what? When the overall cell reaction is happening, you will get this final reaction. Okay, now talking about the ferrous ions are further oxidized by the atmospheric oxygen to ferric ions, which comes out as rust in the form of hydrated ferric oxide. So this Fe2+ which is released on the oxidation of Fe, this Fe2+ is further oxidized by oxygen to give you ferric oxide or hydrates of ferric oxide, which is called as rust here. Okay, now moving to the next question, we have give the products obtained at each electrode respectively when molten NaCl, aqueous NaCl and acidulated water undergoes electrolysis. So when you have molten NaCl, you have sodium and chlorine, sodium at cathode and chlorine at anode. When you have aqueous NaCl, H2 at cathode and Cl2 at anode, and when you have acidulated water, you have H2 at cathode and O2 at anode. Okay, then we have, next we will move to some numerical questions, how to solve these numerical questions. I will not be solving much in detail, I will tell you how to do it and I will tell you the final answer also so that you can check the calculation. Let's move to the first question. So this question was asked in SQP 1 of 2025. So the molar conductivity of 0.025 mole liter inverse methanoic acid is this much, calculates its degree of dissociation. Okay, so first let us see what values are given to us. Concentration is given 0.025 mole liter inverse. Okay, and molar conductivity of that is given, which is 46.1 s centimeter square mole inverse. Okay, its degree of dissociation if I want to calculate. So for degree of dissociation I need lambda m by lambda naught m, right? So what is the methanoic acid is there? So you have HCOOH, that is H plus and HCOO minus. Okay, so H plus value is how much? 349.6, and here we have 54.6. Now if I add these two, 6 plus 6 12, I have this one, 9 plus 1 10 plus 4 14, I have this one, 5 plus 4 9 plus 1 10, I have 1 404.2. okay, s centimeter square mole inverse, s centimeter square mole inverse. Okay, so now we have calculated its degree of dissociation. So degree of dissociation is lambda m by lambda naught m. So 46.1 divided by 404.2. Now if you solve this, you will get around 0.114. Okay, moving to the next question. SQP 1 again from sample paper 1. Two electrolytic cell A and B containing solutions of AgNO3 and CuSO4 respectively are connected in series. A steady current of 1.5 ampere was passed through them until 1.45 gram of silver is deposited at the cathode of a cell. How long did the current flow? Next question is, what mass of copper was deposited? Okay, so how much, for how long did the current flow? What we can do, we have this formula, M is equal to Z into I into T, right? So what I will write, first let me write down the given values. So what is the given values? So what are the given values I have? So first of all we have current. Current is how much? 1.5 amperes. Next we have mass of silver deposited. Mass of silver deposited is 1.45 grams. Next we have how long did the current flow? Time we have to calculate here. Then what was the mass of copper deposited? Okay, mass of copper deposited we have to calculate. So first let us find this time. So for time I have this formula, M is equal to Z into I into T, or Z can be written as molar mass divided by N into 96500 into I into T, right? So what is the molar mass here? Molar mass of, we are calculating silver deposited, right, which is 1.45 gram. So I can substitute here 1.45, and molar mass is 108. Okay, and for silver deposition we need Ag plus 1 electron can give you Ag. So number of electrons involved is 1 into 96500. Current here is 1.5 ampere, and then time you have to calculate. So if you solve this, you can calculate the value of time. I'll tell you how much we'll get for time after some time. Next we'll go to the next part. What was the mass of copper deposited? So if you want to calculate mass of copper deposited by mass of silver deposited, will be the equivalent weight of copper by equivalent weight of silver. Now what is equivalent weight of copper? Molar mass of copper, molar mass, just let me write down M like this. So what is equivalent weight? You have molar mass of copper divided by N for copper into molar mass of silver into N of silver. Okay, now if I have mass of copper deposited is how much, that I have to calculate. Mass of silver deposit is 1.45, molar mass of copper is 63.5, and if you know copper gets reduced by gaining 2 electrons, right? So N factor should be 2 here, and then we have mass of silver 108, N factor is 1. Now calculate this to get the value of mass of copper deposited. In this too you have to do the calculation, and after you do the calculation, time here you will get is 864.5 seconds, and mass of copper you will get is 0.426 grams. Okay, moving to the next question. The electrical, so this is from sample question paper 2 of 2025. the electrical resistance of a column of 0.05 mole liter inverse. So I have 0.05 mole liter inverse as concentration of diameter 1 centimeter. Then diameter is 1 centimeter, length 50 centimeter. Length 50 centimeter and resistance is 5.55 into 10 to the power of 3 ohm. Calculate its resistivity. So what is resistivity formula? So we know R is equal to rho into L by A. So what is resistivity here? R into A by L, right? That is the resistivity. So now, okay, just a minute. I can write like this: rho is equal to R into A by L. Okay. So now what happens if I just solve this? R is equal to 5.55 into 10 to the power of 3. What is area here? Area will be pi r square, right? Diameter is given to you 1 centimeter. So what is the r? Then radius, it is 0.5 centimeter and you have pi r square, okay, 0.5 square. Then R A by L. What is the value of L here? 50 centimeter. So if I solve this, I'll get the resistivity value. Okay. Now once you get resistivity, can we not calculate conductivity? Conductivity kappa is equal to what? 1 by rho. So just substitute here, then you will get that. Then the question is to calculate molar conductivity. So how can we calculate molar conductivity? So that will give me kappa into 1000 by C. Kappa I calculated here, 1000 is there and C is already given 0.05 mole inverse. So what will be the value? Let's see. So the first one, this resistivity value will be, I'll tell you here. So the resistivity value is 0.87135 S. Is it in meter? So now if you solve this, you will get 87.135 S centimeter. Okay. That is, in meter you will get 0.871, in centimeter you will get this much. Now if I substitute this one, the kappa value I'll get is 0.0114. Okay, that is S centimeter inverse. Okay, you got this value. Now if I substitute this one, that is 0.0114 into 1000 by C. C is 0.05. That will give me how much? The final value will be 229.52 S centimeter square mole inverse. Okay, so here answers are in meter, here I have given you in centimeter. Okay, moving to the next question, calculate the Gibbs free energy for the cell reaction given here. Okay, so if I see this particular cell reaction, Fe3+ is undergoing reduction, so that will be my cathode, right? And I is undergoing oxidation, so that will be your anode. Okay, so now if I see here the reaction, what is E naught value? What is E naught of the cell? E naught of the cell is E naught of cathode minus E naught of anode. So 0.77 minus 0.54. So sorry, 0.77. Okay, 0.77 minus 0.54 I'll get. So 7 minus 4, 3. Then I have 7 minus 5, 2. So I'll get 0.23 volt. E naught of the cell I got. Next I have to calculate delta G value. Okay, what is delta G formula? Minus NF E naught of the cell. So what is N value? You can see here only 3 plus 2, 2 plus 1 ion is there, but 2 Fe is there. So 2 electrons are involved. I minus 2 I2, again 2 electrons are involved. So I have 2 into 96500 into 0.23. So that is equal to almost minus 0.46 into 96500. Okay, so if I solve this, I'll get delta G value as around 44300. Okay, joule per mole. Clear? So that will be the answer for this one. Now what we have to also calculate, we also have to calculate the equilibrium constant. How to calculate the equilibrium constant? So now see, we have delta G is equal to minus 2.303 RT log of K. Okay, so this is minus 44300 is equal to minus 2.303 into 8.314 into temperature is not mentioned, so you can take the standard temperature, that is 298 Kelvin, okay, into log of K. So if you solve this, log K value will be somewhere around 7.76. Then if I have K value will be 10 to the power of 7.76, that can be written as 10 to the power of 7 into 10 to the power of 0.76. So that will give me 5.75 something into 10 to the power of 7. Okay, so that is how you can calculate the value here. Next, moving to sample question paper 3, and we have the question, calculate the EMF of the following cell and state whether the cell is feasible or not. So we just have to calculate the E value here. Okay, so if you see Br to Br minus, what is happening here? Br minus is undergoing oxidation to give you Br2, or I'll just keep it 1 electron. So okay, this is the reaction here, and we have 1.09 volt for this one. Okay, then we have next one is for hydrogen, so I can write H plus 1 electron gives me H2, half H2. Okay, and we know that the reduction potential for this one is 0 volt. Now if I add both of this reaction, what I will get? Br minus plus H plus, and you have given me half Br2 and I have half H2, right? This is the final reaction. Then how to calculate the next thing, that is E naught value, right, or E value. E value is equal to E naught minus 0.059 by N value is 1 into log of pressure of Br2 into pressure of H2, its half power will be half here, divided by I have Br minus concentration and H plus concentration. Now you can see what is E naught value. E naught value will be what? E naught of cathode minus anode. So 0 minus 1.09 volt. So that will give me minus 1.09 volt. Okay, cathode minus anode. So minus 1.09. Okay, just a minute. Minus this, I am just taking 0.06 for easy calculation. Then I have log of this pressure is 1 bar, here it is 1 bar, here also it is 1 bar. Then I have bromine minus concentration is 10 to the power of minus 2. Okay, and H plus concentration is 3 into 10 to the power of minus 2. So now if I just solve this log part here, so how much I will get? So 10 to the power of minus 4, that can go up. So I will get log of 10 to the power of 4 by 3. Right, log of 10 to the power of 4 by 3. That can be written as log of 10 to the power of 4 minus log of 10 to the power of, log 3. Log 10 to the power of 4 is 4 and this is log 3 is 0.478. So if I solve this, 4 minus 0.478, 4 minus 0.378, 478. So 10 minus 8, 2, 9 minus 7, 2, 9 minus 5, 4, then I have 3522. Yes, 3.522. So I will get 3.522. This is my log value. Now I can just multiply this value with 0.06. So I have 6 2s are 12, 6 2s are 12 plus 1 13, 6 5s are 30 plus 1 31, 6 3s are 18, 19, 20, 21. Okay, so we have now this 3 and here I have 5 total 5 decimal places, 1 2 3 4 5. So I can have this whole value will give me 0.21132, right? Yes, just a minute. Yes, so I will get how much this one as? Minus 1.09 minus 0.21132. Okay, so now if I solve this, 1.09.21132, okay, so that will give me 10 minus 1.3. Okay, so just a minute, I'll get minus 1.3. If the value is coming negative here, then the cell will not be feasible. So what will be about the feasibility? Not feasible, right? Okay. Let us see the next question here. Calculate the limiting molar conductivity of Cl minus by using the data of lambda naught m for the following. So this is very simple question from Kohlrausch's law. So if I want to calculate lambda naught of CaCl2, that will be equal to this of Ca2 plus 2 times of Cl minus. Now what is molar conductivity of Ca? 271.6, and we have Ca2 plus 119 plus 2 times of molar conductivity of Cl minus. Now 271.6 minus 119, so that will give me 6. Then I have like 6 plus 9, 10, 11, 5, 152.6, okay, divided by 2 into Cl minus. So I have 2 sevens are 14, and then we have 276.3, right? Yeah, 76.3 will be the molar conductivity of Cl minus ions. That is what we have to just calculate. Yes. Next, here this unit is wrong. Don't have to check this unit. So molar conductivity unit is S centimeter square mole inverse. Okay. Next question, we have the standard electrode potential of Daniell cell is 1.1 volt. Calculate the Gibbs free energy. Okay. So PYP 2025, this is very simple question. So what is the formula of delta G? Delta G is minus NF E naught of the cell minus 2 into 96500 into E naught of the cell is 1.1 volt, right? So if I solve this, you will get around minus 212.3 kilojoule per mole. Next question is from conductivity of 0.001028 mole liter inverse acetic acid is this much. Calculates its dissociation constant if lambda naught m for acetic acid is this much. So this is very simple. First of all, you need to calculate the molar conductivity, that is equal to what? Kappa into 1000 by C. So what is the value of kappa that is given to me? 4.95 into 10 to the power of minus 5. Then I have into 1000 divided by CE 0.001028. That value you have to calculate. Okay. So just a minute. Yeah, this will give me molar conductivity value. Next, after solving this, so if I just solve it 4.95, so you will be having calculator, you don't have to worry for that. And here I can write it as 1.028 into 10 to the power of minus 3. So this goes up. So I can have 49.5 divided by 1.028, right? So 49.5 divided by 1.028. Now if I solve this, you will get 48.1 as the molar conductivity, S centimeter square mole inverse. Now what you have to calculate? You have to calculate the degree of dissociation, right? So that is what? Lambda m by lambda naught m. So lambda m value is 48.1 and lambda naught m value is 390.5. Now if I solve this, you will get around 1.56 into 10 to the power of minus 5. Okay. Next, okay, so that's all in the numerical part. So I want all of you to try this numerical. If you find any question is difficult or any answer is not matching, please put down in the comment section. I'll definitely check it. So thank you for watching and all the best. Practice all these questions. If you have further any doubt, do let me know in the comment section. Okay, all the best dears, and please keep working hard, keep smiling, and all the best.